Okay, so I ended up with this last section, and I really should have finished with one more, and I'll mention it right now. That another solution formation, something that can affect solution formation is pressure. And again, this deals with gases, so it doesn't deal with solids and liquids because it's not affected by pressure. You know, by putting sugar or salt in water under high pressure is not going to make any effect. But in gases, you increase the pressure, there'll be an increase in solution formation. So again, what this basically means is when companies that make carbonated beverages, they do it under very cold temperatures. They try not to shake them up so the solutions can also, so the bubbles can stay in there. And they also do it under high pressures. So you increase the pressure, solution formation. And again, think of it as soda. You know, you've got a bottle of soda, carbonated water. That's under some severe, some significant pressure. As soon as you release the cap or unscrew the cap, that releases some of the pressure, and so all those bubbles come out of solution. If they didn't pressurize them, then sodas would be flat all the time. So that was the fourth one. I just certainly don't want to forget about that. Moving right along to solubility. Quickly, solubility is the amount of a solute that dissolves in a given solvent at a specific temperature or pressure. Okay, again, temperature and pressure because gases can be affected by that. So, three different types of solubilities here. We have an unsaturated solution. An unsaturated solution contains a less solute than can be maximum amount. Saturated solution, and I'll put them both at the same time because obviously in the unsaturated I put saturated, but a saturated solution contains the maximum amount of a solute for a given amount of solvent at a constant temperature and pressure. So whatever that amount is, so you've got some water here and we have some salt, okay, there's going to be a limit where you put salt, and then no more will be dissolved. All the salt that can be fit in that solvent is maximized. So you can't put any more. That's what a saturated solution is, okay? Anything less than that is unsaturated. It means you could put a lot more. So, of course, if you have a certain amount of water, you put some salt in there, you put a little bit, 2 crystals, you can probably put more. It's unsaturated until it gets to the point where no more will go in solution. A supersaturated solution is a solution that contains more than can be theoretically held. And so you say, well, you're talking about a saturated that's maximum amount of solute, but what's more than the maximum amount? Well, let me just quickly mention this. Okay, so saturated is the max that you can have. Supersaturated is even more than theoretically can be held. Supersaturated solutions are formed by increasing the temperature. So you notice the previous slide said something along the lines of, here, let me just go to previous, at a constant temperature and pressure, versus by increasing the temperature. If you increase the temperature of the solvent, you're allowing those molecules to move around a little bit faster. They can actually dissolve more than the maximum amount. So you elevate it, you put more in, and then you allow it to cool, and that solute will stay until a seed crystal or there's some agitation or something which will allow for quick recrystallization. So again, this happens a lot with crystal formation. It's supersaturated solution. You touch it, you introduce some dirt to it, you put a seed crystal, another one of the crystals, and it completely recrystallizes. And I'll show you a video on that as well, and we're going to do that in class, okay? But that's supersaturated solution. So, quickly, types of solutions. Types of solutions, we've got solid solutions. These are your alloys, combinations of metals melted and combined. So brass is an example of an alloy. Bronze is an example of an alloy. Brass is copper and zinc. Bronze is copper and tin. It's kind of the opposite than what you'd hope. I mean, brass has the S, but it's the ZN. Notice that bronze has the Z, but it's SN. But just the brass and bronze, it's a combination of metal melted down and combined. It creates a solid solution. It's an alloy. These are usually stronger than the original. So brass and bronze are both stronger than copper and zinc on their own. Well, let me just quickly go back. I mean, certainly not pure gold, so like 14 karat gold, so your jewelries or whatnot, 18 karat gold, stainless steel, these are all alloys. 14 karat gold is a lot stronger than 24 karat gold. You know, my ring is a combination of platinum and yellow and rose gold, and you know, it's pretty hard. Certainly that's the platinum. The gold, if that gold part was 24 karat gold, by just doing that, by smashing it on the desk, it would completely flatten and be deformed. Gold, we know, is very, very soft. It's very malleable. By alloying it, by making a solid solution, we can make it a lot stronger. So that's what alloys are. Gaseous solutions, air. Obviously, if we have a balloon that's filled with nitrogen and carbon dioxide and hydrogen and oxygen, this is just a gaseous solution. Of course, the air all around us has got a bunch of different gaseous molecules in it. Okay. The next two, liquid solutions. Liquid solutions are most often with water versus aqueous solutions. Just know the difference. Liquid solution doesn't have to have water, but a liquid solution would be like the oxygen in the water that's dissolved. We don't see bubbles floating around in water, but there's obviously oxygen in there. Fish need to breathe, and they're not breathing the O off of the H2O. If they did that, then there wouldn't be any more H2O. It'd be just H2, and we'd have, you know, a pond with fish would not have water in it because they'd be using all the oxygen to breathe. So they're using the dissolved oxygen in the water. Aqueous solutions, which you can see are commonly described with a little AQ afterwards, that's a solid dissolved in water. So if we see this NaCl AQ, that means it's an aqueous solution of salt. Salt has been dissolved in water, and it's an aqueous solution. So you get your solid solutions, gaseous solutions, liquid solutions, and aqueous solutions. Different types of solutions.